Class, this is lecture 10, Eigenvalue and Eigenvector. In this lecture, we discuss how to find the eigenvalue and eigenvector. Now, what is eigenvalue and eigenvector? So, let A be the square matrix of order n, and suppose we take a linear transformation, that is y is equal to ax, where x is what? X is a column vector, or say is a vector. And if this linear transformation transform that x into the scalar multiple of itself, that is ax is equal to, we get a scalar, that is lambda x. So that lambda that lambda is known as eigenvalue, and that x corresponding, that x non-zero vector x, we say is eigenvector. So here ax is equal to lambda x, this is a transformation, and we get our lambda x, and this lambda is what? Eigenvalue of the matrix, and this x is what? Is eigenvector of that matrix. And physical interpretation in the terms of vector, we can say this: we have in a vector, suppose x, and this is the position of that vector in that direction. So a matrix, suppose a matrix A, act by stretching the vector x to that point, but not changing the its direction. The direction is same as the vector x. So that x is what? Is an eigenvector for that matrix A. In another example, this is a picture. In that picture, you see, in that figure, you see the red arrow and the blue arrow. And the same picture, if that picture is just tilted, but you see the blue arrow, that blue arrow is not change the direction. So this blue arrow is shows what? This is an eigen vector. So you remember that red arrow change the direction, but the blue arrow does not change. So the blue arrow is what? Is an eigen vector of this shear mapping, because it does not change the direction. Since, and we can say, since the length of unchanged, we can say, because the length is unchanged, so its eigenvalue we can say is 1. The equation that ax is equal to lambda x is known as characteristic value problem, because these are the equation. Then we write ax minus lambda x is equal to 0, or if we take x as a common, so we write a minus lambda, we write in, and x is equal to 0. Here in is what? Is a unit matrix of the order n, because the order of the matrix we take is what? N. So this equation, that equation represent what? Is a system of n homogeneous equation in the n variable, or says n unknowns. And this is what? This is a homogeneous system, and which has non-trivial solution. What if the coefficient of that matrix, that matrix is what? Is singular. So that is, we can say, the a minus lambda in is equal to 0. This is what? This is the determinant of that matrix. Means of the matrix, that matrix, this is the coefficient of x, that matrix is what? Coefficient of x. So if this is singular, so we obtain a non-trivial solution of that system. Or we can say this is singular. What it means? Singular means the determinant of that matrix is what? Is equal to 0. So here you have to remember the equation a, determinant a minus lambda in is equal to 0 is called characteristic equation of a. On expanding the determinant, the characteristic equation can be written as a polynomial equation. Means if we expand that equation, this become a polynomial equation, and if we get an equation, then definitely we have a root. So the root of that characteristic equation, says lambda 1, lambda 2, lambda n, are called characteristic value, or latent value, or the eigen value. And the non-zero solution of that equation is called characteristic vector, or eigen vector. how to find the eigenvalue and the eigenvector. So take an example. Find the eigenvalue and the corresponding eigenvector of the given matrix. And we take an example for the matrix of order 2 cross 2. So first we write the characteristic equation. Characteristic equation. Here we just consider eigenvalue, that is, let lambda be the eigenvalue, and capital X we consider the eigenvector. So we write A minus lambda I determinant is equal to 0. This is what? This is a characteristic equation. So here we have to find the lambda. So first we write in that form the matrix. We have given a matrix A, that is 8 2, and this is the lambda. We take just this is the eigenvalue, and this I is what? Is an identity matrix of order what? We take 2 because the given matrix is of order 2. So now we write here what? We just write, you can also write 8 minus 4 2 2. You write the matrix A of the determinant of matrix A, then lambda, and then write the identity matrix. Determinant of identity matrix 1 0 0 1. This is of order 2 cross 2. Now when you write, you can write that determinant in that form 8 minus 4 and minus lambda 4 minus 4, and this will become what? 8 minus lambda I is what? 1. So this is 8 minus lambda, then minus 4 minus lambda into 0 0, so we write just minus 4, then 2 minus lambda into 0, so we get 2, then 2 minus lambda and into 1, that is 2 minus lambda. So, and after expanding that determinant, what we get? We write 8 minus lambda into what? 2 minus lambda minus 2 into minus 4, that is minus 8. We write plus 8 is equal to 0. On solving that, we get an equation, that is lambda square lambda 2 lambda minus 8 lambda, that is minus 10 lambda, and 8 into 2, that is 16 plus 8, we get plus 24. We get a quadratic equation. So this is what? This is a characteristic equation. So if the matrix is of order 2 cross 2, so we get the order the equation of order 2. Now when we solve that equation, or we find the root of that equation, what we get? We can write that equation lambda minus 4 and lambda minus 6. We get a two factor, that is lambda minus 4 and lambda minus 6. So we can say lambda is what? 4 or 6. So here we get two eigenvalues, that is lambda is equal to 4 and lambda is equal to 6. We just write this is lambda 1 and this is lambda 2. So here we get two eigenvalue for the given matrix. Now we find the eigenvector for corresponding these eigenvalue. Now we find the eigenvector to the corresponding eigenvalue. So first we find the eigenvector to corresponding to lambda 1 is equal to 4. So let us take the eigenvector, so it's x1. This is what? This is, we say x1 or x2. So we write then a minus 4I, that one is x1 is equal to 0. This is what? This is lambda I, this is lambda 1. So or you can right? The x1 is what is an eigenvector. We just consider the eigenvector. Why we take the eigenvectors column of unknown variable 2? Because the given matrix is of order 2 cross 2, and that matrix is generated by the system in which we have two unknown and two equations. Then you just write a is what is the matrix, that is 8 minus 4 minus 4 2 2 minus 4, and here we write the eigenvector, that is x1 or x2 is equal to 0. So here what we do, we just simplify that. We get 4 minus 4 2 minus 2 x1 x2, and then convert it into the equation. We write 4 x1 minus 4 x2 and 2x1 minus 2x2 is equal to 0. So we get an homogeneous system of linear equation in which we have two equations and two unknowns. So if we solve that system, so what we get in both the equation implies what? x1 is equal to x2. So here we can say, let if we take x2 is any arbitrary value k, which is arbitrary value, we take an arbitrary value k, so we can say x1 is also k. So here what we can say, the eigenvector, that is x1, x capital x1, that is what is a small x1 and x2. So we write k or k. So any arbitrary value, if we take in the any arbitrary value to the k, so we get, suppose it would be 1 1, so we can say x1. This is what, this is an eigenvector corresponding to eigenvalue, that is lambda 1 is equal to 4. We can also take that k is equal to 2 3 4, but so we take just 1 at its in standard form. We take a 1. You can take also a 2 3 4, any arbitrary value for that eigenvector. So this is what, this is eigenvector, and this is a corresponding eigenvalue, or we can say for that corresponding eigenvalue, this is the eigenvector. Now for the eigenvector 2, lambda 2, that is 6. So we let take capital X2, the another vector. You just take y1 y2. Again we write a minus, what we write, lambda is what now, 6 I matrix, and this is x2 is equal to 0. Then we write 8 minus 6 minus 4 2 2 minus 6, and here we write y1 y2. Convert that into a system. We can write 8 minus 6, that is 2 minus 4 2 minus 4, right? y1 y2, convert it in the equation. We get 2 y1 plus minus 4 y2 is equal to 0, and the second equation again we get 2 y1 minus 4 y2 is equal to 0. On solving that equation, again we get what, because you already solved that system, this is a homogeneous system, and here the rank of the matrix or coefficient matrix is less than the unknown, so we can say it has trivial solution, means non-trivial solution, many solution, or say infinite solution. So this equation implies y1 is equal to 2 time of y2. So let take y2 is any arbitrary constant, says, now we take the, says a, so y1 is what, 2 time of a. So we can say the eigen vector x2 is what, is a and 2a. If we take a as a 1, so we write 1 and 2. So we get an eigenvector corresponding to the eigenvalue, that is what, this one, lambda is equal to 6. So this is the eigenvector 1 and 2 corresponding to eigenvalue lambda 2 is equal to 6, and that is the eigenvector corresponding to the eigenvalue lambda equal to 4. Now taking another example, find the characteristic root and the corresponding characteristic vector of the matrix. That means we have to find the eigenvalue and eigenvector. So first what we do, first we write the characteristic equation, that is of the matrix A is A minus lambda In. This In is what? Is the order of that matrix. So the order of that matrix is what? 3 cross 3. So we write that is 3, I3, identity matrix of order 3. So what we obtain, the characteristic equation, that is 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda. So we just subtract the lambda in the diagonal because we have an A minus lambda I. Lambda is multiplied by the diagonal of that identity matrix and we just subtract it into the matrix A. So this is what? This is a determinant which is equal to 0. So this is the characteristic equation. After expanding that determinant, we obtain a characteristic equation. And what is that? We obtain an equation that is lambda cube minus 18 lambda square plus 45 lambda is equal to 0. And we just simplify that equation. So we get lambda minus 3 lambda minus 15 is equal to 0. So we get a 3 factor, that is lambda minus 3 lambda minus 15 is equal to 0. So we get 3 values 0 3 15. So we have 3 eigenvalues. Says lambda 1, that is 0, lambda 2 we say 3, and lambda 3 we say is 15. So we have 3 eigenvalues of the given matrix. Now we find the eigenvector to corresponding these eigenvalues. For that we just write the eigenvector of the A corresponding to the eigenvalue 0. First we find the eigenvector corresponding to the eigenvalue 0, which is given by what? A minus 0 I x is equal to 0. We write an equation. So here what? A is what? 8, that matrix, coefficient matrix, 8 6 2 minus 6 7 4 2 minus 4 3, and we write a vector, that is we take a vector x. Here we take x1 x2 x3 because this matrix is obtained by the system of linear equation of order 3, or we can say we have a in the system where where that matrix, coefficient matrix is obtained. In that system we have 3 equations, so we have 3 unknowns. So we just take a vector x1 x, that is x1 x2 x3. Now this is what? This is a homogeneous system of equations, and how to solve the homogeneous system we were discussed in the previous lectures. So first we convert that coefficient matrix into the echelon form by using some row operations, and then discuss the rank, and then we discuss the solution of that system. So we apply the operations. So we can for first operation we can apply we interchange that r3 with r1. So it is convenient to simplify that system, yeah, or say convert into that system into the echelon form. So we just interchange r1 with r2. So we obtain that matrix. Then we apply by the help of that matrix. This is called the pivot element or the leading element. So by the help of that element, make these element, make it 0. So we apply the operation on r2 plus 3 time of r1, and on r3 we apply r3 minus 4 time of r1. So we obtain what? 2 minus 4 3, 0 minus 5 5, 0 10 minus 10. Now by the help of that row r2 we can we search the leading element, or we say we search the leading element, the second row non-zero element, that is minus 5, and by the help of this make the below element 0. So so we apply the operation on r3 by plus 2 time of r2. So we obtain 2 minus 4 3, minus 5 5 0 0 0. Now come to the third row, we search this, all element are 0. Now it become what is an echelon form of that matrix. At that stage we can say the coefficient matrix, that is A, this coefficient matrix A has a rank what, 2, and there are three unknowns in that system. So we can say we have rank is 2, and therefore the equation we have unknown is 3. So 3 minus 2 is 1. So we can say 1 is linearly independent solution. So that system has one linearly independent solution. So the above, now at that stage we convert the system again into the system of equation. So how we write, 2 into x1 minus 4 into x2 3 into x3 is equal to 0. The first equation we obtain, minus 5 into x1, sorry minus 5 into x2 and 5 x3 is equal to 0. So we obtain two equations. And now at that stage, as you know, that system has what, infinite many solutions. So we choose an x2 from that equation, we get a relation. And what is that relation? We get x2 is equal to x3. So we just take, and x3 is an arbitrary, or x2 is an arbitrary, says k, and is scalar, so x2 is also k. Then from the first equation, what we get x1 is equal to k by 2. We have x2 is k and this is k, we get minus k, so we get k by 2. X1 is k by 2. So now what is x2? Here the vector which we take, that is x1, we take what, x1 x2 x3. So here we take a k by 2, k and k. If we take k as a common, so what we get, 1 by 2 1 1. So this is what, this is an eigen vector. We can say this is an eigenvector of A corresponding to the eigenvalue 0. So the eigenvector of A corresponding to the eigenvalue 3 is given by, we write A minus 3i x is equal to 0. So the system, we write, we get an coefficient matrix 5 minus 6 2 minus 6 4 minus 4 2 4 0, and we take a vector. We say suppose this is x2 vector which is corresponding to the eigenvalue lambda equal to 2, that is 3. We take x2. So here we apply the operation on the matrix and convert it into the echelon form. We apply just an operation on r1, we replace with r1 plus r2, it become minus 1, and by the help of this one make these elements 0. We apply the operation on r2 and r3 simultaneously, we get 0 and this becomes 0 16 8, and by the help of that element, second leading element of second row, the below element 0, we apply the operation on r3 plus 1 by 2 r2. So it become, now at that stage it becomes the echelon form. Now what this particular matrix A, or say coefficient matrix, rank has 2. So we have 3 unknown and the coefficient matrix of rank 2, and we have 3 unknown, 3 minus 2 1, it means one linearly independent solution. Or we can say this system has what, the linear infinite number of solutions, many solutions. So convert that system again into the system. So we get two equations, that is minus x1 minus 2x2 minus 2x3 is equal to 0, and 16x2 plus 8x3 is equal to 0. So by solving that system from that particular equation 2, we get what, x2 is equal to minus 1 by 2 x3. And when we put it into the equation 1, so we choose x3 says k, so x2 become minus k by 2, k is any scalar. And when we put x2 and x3 in equation 1, so we get x1 which is minus k. So we can say the vector x2, this vector x2 is what, we take a k as a common, so we write minus 1 by 2 and 1. So this is what, this is an eigen vector of A corresponding to the eigenvalue 3. So Similarly, the eigenvector corresponding to the eigenvalue 15, we write a minus 15 I x is equal to 0. So we get an equation what? Minus 7 6 2 minus 6 8 minus 4 2 minus 4 12. And this is what? This we take the eigenvector, suppose x3. We just take x3. X3 is what? Is an eigenvector corresponding to the third eigenvalue, that is 15. Then again we convert, this is what? This is a homogeneous system. We convert that coefficient matrix into the echelon form by the proper row operation. We just apply the r1 minus r2, so we get this. And then we apply the on operation on, by the help of that we make this element 0, r2 minus 6 time of r1, and r3 minus 2 time of r1. Now at that stage it convert into the echelon form, and we can say the rank of that matrix is what? 2. So there is, we have three unknowns, so we can say there is one linearly independent solution, or we can say that system has infinite many solutions. So we convert that system again into the equation. We write minus x1 plus 2x2 6x3 is equal to 0, and then 20 minus 20 x2 minus 40 x3 is equal to 0. Now the second equation, it implies what? X2 is equal to 2 time of x3, and now we choose x3 is k, then x2 become minus 2k, and when we put x3 and x2 in equation 1, so we get x1 is 2k. So the vector is what? The eigenvector is 2k minus 2k and k, so we take k as a common. So this is what? This we can say is an eigenvector of a corresponding to the eigenvalue 15. Okay class, the remaining part of the eigenvalue we cover in the next lecture. Thank you.